Thank you, and hello everyone, and nice to meet you, and nice to thanks for the organizer for creating and involving me in this event. So today I want to speak about one of the projects that I worked with uh, in Italy and in Canada during my PhD research. The short name is RepMat Library, but I will speak about this later on. I'm giving just now some brief information about my work. I am a postdoctoral researcher in FastLab in Western University in Canada, and my background is mostly connected to product design and materials engineering. In fact, I previously worked in Italy for 7 years in a lab that is connected with both the design department and the department of chemistry and materials there, where I worked for my PhD in design and before for my Master of Science in Design Engineering. This means that I'm very connected both with the product part of projects and the material side. And what I really want to do is try to work with my work in connecting these fields, design, engineering, especially for sustainability. And my way for making it's working on materials and 3D printing. I can say that my work is mostly connected with open design and circular materials for sustainability, and that digital fabrication and engineering are my ways, my media for working on that. And I'm working on this connected with 3 labs where I'm involved and I have the pleasure of working with. The first one is one lab close and connected with Politecnico di Milano in Italy at the Department of Chemistry, Materials and Chemical Engineering. And that was the first 3D printing lab in Politecnico di Milano working on 3D printing technologies. There, I had the opportunity to work on new materials and technologies for 3D printing, also connected with sustainable materials and new field of application, especially new assistive technologies. And my focus was mostly on social and environmental sustainability as the one for the lab. The second lab I was involved in Italy was Materials Design for Transitions Lab in the Department of Design here at Politecnico di Milano. And in this case, the focus was working on the role of designers connecting materials, engineering, but also try to envision thinking with materials and understanding what material can give to the design process. And in this case, my focus was working on sustainable practices through materials for designers, but also regenerative ones. My last lab that I'm presenting and the one that I'm currently involved is FastLab, the Free Appropriate Sustainable Technology Research Group. And now I'm working with them as postdoc in Canada, where the focus is working on distributed recycling and additive manufacturing. So trying to find a way for connecting all the dots that before I was involved in, and then thinking about how to use them for sustainable energy and technology. And what I'm working currently can be seen as something between sustainable development and accessible technologies. So all these labs together, we can say that they have some common points, but which are these shared interests and goals? I would say it's the act of making and the will to make all these acts open. And that can be also translated in different things. Can be products, artifacts that are open, technologies, processes, resources and materials, and also sustainable practices and circular practices. The first 2 are probably the ones that are mostly connected with what is open hardware, while the second one sometimes are a little bit trickier to also share. So how to share materials, how to open the use of materials. So what I want to think, it's mostly try to see if the aim of my work also connected with the labs are the will to open this knowledge, so to open materials and technological knowledge. And what I was trying to work, and I'm working with during RepMat, is opening materials and technological knowledge to try to foster collaborative making and sustainable practices. And in this case, I have to just introduce a little bit what is materials knowledge instead of technological knowledge. We can say that a specific material can not only be described by the physical and technological properties, or, for example, materials properties that are more from the hardcore engineering side, but also from the expressive sensorial properties that they can be perceived by users when they are touching them, experiencing, and giving a meaning to a product. And for this reason, what I'm interested in is working with both the physical and technical properties and also the expressive sensorial qualities. The first ones are mostly quantifiable, objective, can be measured, can be quite clearly quantified, and usually are textual content or data, while the second one are quite tricky to be measured. So many times are not quantifiable, are subjective, are also depending on the user experience or their background. And many times are also connected with something that is not textual or is a tacit knowledge. So how to use something, how to manage a specific material, how to manage and use a product. So what is done in this case is trying to really measure and understand how this tacit and non-textual knowledge can be measured through, and how also can be these connected and with practical experience. So many times we need, for this reason, tangible artifacts for conceptualizing and transferring this kind of non-textual knowledge. And here the main trick, so how to transfer different materials and technological knowledge, including the tacit and non-textual one. For this reason, usually we should see, touch, experience with materials, with sample. That's also what is involved in the act of making. And many times what we do is learning by interacting with these materials. And what we want to do and what we want also to transfer many times is this learn by doing an experiential approach and knowledge. Experiential knowledge, to this extent, is something that comes from interacting with the materials and learning by experience. So these experiential approaches are mainly involving experiential tools. These tools are something that helps user to transfer and acquire this knowledge. So these tools are also facilitating this knowledge transfer. And many times they are mostly focused on quantifiable aspects, like can be properties or qualities, and they usually rely on practical approaches. Can be index, can be brainstormings, but can also be materials libraries, as RepMat. What is a materials library, first of all? Materials library is a collection of different samples organized according to different criteria or taxonomies, and they give a direct experience and interaction to the user. So the user can directly see the samples, touch them, compare, organize according to different orders. And usually, especially from the beginning, this is mostly connected with tangible objects, tangible samples, with different finishing, with different technologies, and linked with the textual informations. But nowadays, there are also virtual database, virtual contents through images, rendered, and models. And these databases are usually together with the rest, because the most important thing for materials library is to be easily used and accessible, and the sample should be easily touched and used. So what they usually do also in this case, materials library, materials database, is to create a bridge and dialogue between disciplines, between designers, engineers, technicians, and try to share the use of emerging materials, which is also similar to FabTasks and Makerspace, and that's why I was then involved. But what if we try to open materials libraries by making them globally accessible and locally replicable? So that's why I'm speaking today about RepMat. RepMat is the replicating materials library. Obviously, is inspired by the RepRap project. So I took inspiration from them for the name and also the way of using and behaving with the materials libraries, because it's an open materials library system that wants to be replicated, used, modified, also shared to create new materials and technological knowledge with users in local spaces. In this work, I was working with different partners, so my labs in Italy, in Canada, and then also other industrial partners for providing us the materials. And I focused mostly on working on 3D printing and polymer and biomass waste. And Finally, what is included in RepMat is a virtual part made of a materials library and a product library, and a physical part made of physical samples of materials and products for a participative experiential approach to new knowledge. And in this, there were also some potential applications that we developed during our work in the lab, also together with the students I worked with during these years, connected with furniture, music, sports, and this library is meant for being used in two ways. The first one is in a divulgative way, so sharing the knowledge that we build in the labs, but also in an experimental one, so trying to create new knowledge, try to use the library as a tool for replicating materials, and every time that we replicate, learning something new. So for this reason, there are the two parts, the materials library, the product library that provides the physical fruition to the system with material samples, also cutoff or application, connected to a virtual library that gives all the textual data. And I just hope that the video is working, seems not. I had a video, but I don't think it's working. So what I will do is just probably sharing later if I can. If not, we will just continue. And how it works, so the tool is meant to be used in an iterative way, so using, replicate, modifying, changing the samples that we are using, and using it locally, so replicating in local space, but connecting online with the virtual library at a global level. Also because this can give, on one side, the tangibility of materials, so the tangible fruition, the tangible experience with the samples that you are building, and on the other side, also what a network can give, so a virtual network that can be connected to study new materials, to share new practice, and to share also the results. And for this reason, what is also possible to do with this kind of tools is sharing not only the textual information, the pictures that we did, but also everything else that comes from experiencing and experiential learning. So how to handle and touch some materials, how to use them, how to try to embed them in new products, if there are specific aspects to be considered during their use. And for this reason, I designed the system following some specific taxonomies, one for the materials library and the second one for the product library. The first one is mainly connected with a three-variable system. So the first variables are set, can be the ones that the users wants to use, can be, for example, for 3D printing, can be a specific material, a specific ways used in the 3D printer. And according to that, we can define a space with the three different variables where each coordinate corresponds to a specific product sample that changes and has this a specific combo of the different variables. For example, here, as you can see as an example in the recycled PLA matrix that I did before, where I was changing the type of recycled PLA and the contents or the colors and finishing. And the same thing can be done also for the product library, the ones that also include some cutoffs and samples. So in this case, I divided the space in four dimensions with the fourth variable connected with the shape itself, divided it in different grids. And then according to the grid, every single sample can give a different combination of the properties that I want to work with. For example, as I did here with the recycled PLA 3D printed with the large scale 3D printers, where I was changing the kind of shape, the kind of specific PLA after different recycles, or also the finishing or the layer height. In total now we are at almost more than 200 samples, but new samples are coming soon. And what I was really, let's say, interested in was also try to make the whole structure that is physical, replicable abroad. So I tried to develop different kind of structures according to the specific needs and materials that are locally available. And for this reason, all the structures can be replicated with less than 20 euros according to the materials you want to use. Can be, for example, wood board, can be acrylic. You can just change the technology you use for creating them and just use them and replicate them in your own space. I did some user tests with the students where I was working in Polytechnico and had their opinions. And for these also, I tried to modify the system. I also worked with a student for trying to replicate the library itself. And I did some demos at fairs and exhibitions, and I hope to do them also very soon. This also because in my case, I think that the act of making, it's also connected to the will of democratize knowledge, in my case, materials and technological knowledge. So here, I don't want to give some conclusions, but more like openings and starting for this work. So I really welcome you to join and ask me and discuss more, because I really want also to replicate this tool in other places and include in the online library also other samples from different labs. And that's it. Thank you for your attention. I'm really happy to be here with you. And I leave here some of my